The speed of the gravitational electromagnetic waves is another one. Supersymmetry is another one. We're learning.
Yeah.
We're learning things which are all relevant toward quantum gravity. And there's also a lot of attention now in doing toward doing experiments
Which is always healthy, right?
quantum gravity.
Yeah.
There is one experiment which has been proposed, which I find very exciting, which would not distinguish between quantum gravity theories, but would prove that space is quantized, so that gravity is quantized, which has been proposed by two independent groups last year or 2 years ago. And I'm very excited about it. So I hope people would do that soon. And so let me explain it, because you take one particle, a sort of nanoparticle, small things that people now know how to work with, and you quantum split. You put it in a superposition of two positions. And you take another particle, and you also quantum split. And these two particles, both split, are next to one another. So now there is the gravitational interaction between the two. So each one is in the Newtonian field of the other.
So when we say nanoparticles, this is not an elementary particle like an electron. It's like a little mote of dust.
This is small dust. This is a small grain of dust, right? And these, them, the people in the laboratories are able to put in a quantum superposition of two different positions. So you have two particles, both of them in a superposition, next to one another, and so each one of them feels the gravitational force of the two branches in which the other one is. And because of that, the state of the two particles gets entangled. And now there are very clean ways to see if two things are entangled.
Yes.
And if we find that they're entangled,
and this is true quantum entanglement.
It's quantum entanglement. This is true quantum
entanglement. Not just they're related, but they're connected at this deep quantum mechanical level.
Deep quantum mechanical level. If this happens, it means that the gravitational field itself was in a superposition of two different, was on two branches, so to say. And since the gravitational field we know is space-time, it means that space-time can be put in a superposition.
And this is a proposed experiment.
This is a proposed experiment, but if you work out the numbers, the people who manipulate these small particles, they say that they think they should be able to do it in a few years.
Okay.
And I think it would be wonderful, because there are still people around, even if a minority, who says, I don't believe that space-time has a quantum properties.
I've met them, yes.
And
I never think about why or how it manifests. It kind of just does. Things seem like important in some way, or unimportant. Like something so kind of redundant to be like labored over for days. And like, I'm of a generation that never used a telephone box. It's quite weird. Quite weird to paint them. Yeah. And it doesn't. Not sure. It's kind of. There's this idea that like can't really put it into words. It's kind of how I feel about it. Just quite curious. But yeah, not being able to put it into words speaks 1,000 words.